Hello children, we are back with circle theorems and this is type 3 questions. In this particular video, we'll learn to find the unknown angles inside a circle. Interesting? So first we'll understand two theorems which actually help us to solve these kind of questions. Okay, you can always go to our website examprep.world, open the learn and practice zone. In there you will have topics, you can choose circle theorems, and there we are actually trying to do type 3 questions. So you'll have all questions which are similar, and this is the question which actually figure out in criteria A in your exam. Okay, so be very careful. Even you may be able to do applications, but criteria A should not be losing marks. So let's start to do these kind of questions. Before that, as usual, let us understand the theorem itself. It helps. So we have a circle here. It doesn't look like a circle, but fine. Okay. Now if I take 2 points A and B on the circle, so if I see this line is an arc, okay, but if I join AB, it will become a chord. AB straight line is a chord and this curved line is a arc. Okay, now this particular thing can create angles on the same segment. Now this is segment, this is major segment, this is minor segment, part of the circles which a chord divides the circle in two parts. It's called segments. Okay. Now the bigger one is major segment. Now AB can create how many angles? On infinite number of angles. So let's begin. Suppose it creates an angle here. It is created by AB. So we call that the chord or an arc is subtending an angle on the segment, on the same side of segment. So this is one of the angle. Let me write it C. AB can create one more angle somewhere here. It can create some more angle. It can create, see all these angles C, D, E and F. All these angles are created by which thing? AB, on the same side of the circle. Now what's the property? The theorem says all these angles will be equal, right? You have to remember this. All C, D, E and F. These angles are equal. Theorem says that angles subtended by a chord or an arc on the same segment are equal. Now if this chord subtends some angle over here, they will also be equal. Let me show you. Suppose it is subtending this angle here or an angle here. These two angles will also be equal, same rule. But they should be on the same side of circle. Okay. So with this theorem, this is one of them you should remember, right? And the next one is another one which is simple. Now this chord, our chord or arc AB, here two things are there, arc as well as chord. Okay. Now it was subtending an angle on the segment, but it can also subtend an angle at the center of the circle, correct? It can create an angle at the center or on the segment. It can create two different kinds of angles. Now the relation between this angle AOB will be double of ACB. If this is theta, this is 2 times theta. You should remember this one. This is second important theorem. Okay. If this angle is theta, this is 2 times theta. Now what will be the value of this one? This is on the segment, so it has to be theta only. What is the value of this one? Also theta. At the center if the chord is making, it will be double of the angle which it makes at the segment. That one you have to remember. Okay. Now with these two theorems, we have understood these two theorems. Let's begin our questions to find the unknown angles in the circle. So interesting questions coming up. First one is here. They are asking you to find x and y. If it is 96, remember I told you this is 96. So this angle will be double of this. What is 96 divided by 2? 48. So y is how much? 48, because the angle which BC is an arc. Here chord is missing, but arc is still available. Arc is making an angle in center, arc is also making an angle in the circle. So obviously this on the segment the angle will be half of this, or this is double of this one. So 96, 48. Now what is x? 365 minus 96. Okay. Now what about this? One more beautiful thing I will show you before we go to this question. Okay. Let me go back to the previous page. One more beautiful thing. Now suppose we have a circle and we have a chord here. It is making an angle on the circle and it is also making an angle at the center, A, B. I told you this is 2 times 2 theta and this is theta. Now if I take this A and B, move it here. B is moving in this direction and stops here. B reaches here. And A is moving in this direction and A stops here. Right? Now what will be the diagram looking like? Okay. Will it look like this? This has opened up like this. Okay. So I'll erase this part now. ABs are no more here. So AB has reached, AB has become what? Diameter of the circle. Right? Now AB is creating an angle here, which it was originally also creating. Now this is how much? 180 degrees. It's a straight line. Right? Because AB traveled and became a straight line. So this angle should be half of this. This angle will be 90 degrees. Okay. Why a triangle in a semicircle is right angle triangle? This is the reason. Because the angle in the center is double of the angle at the segment. Easy to understand? So in other ways, the shortcut of remembering this is triangle in a semicircle is always a right angle triangle. You create any triangle. You create like this. This should be 90 degrees. You create here. This will also be 90 degrees. So whenever you draw any triangle in any semicircle, it has to be 90 degrees. So we can come back to the question where I saw a question here. Though AB is a diameter and it is creating an angle X. So this has to be 90 degrees. Okay. Now if this is 68, how much will be Y? 90 minus 68, 22. Correct? 68 plus 22 is 60, 80, 90. So 90. So altogether they are 90 degrees. So you have found X and Y. Relatively simple question, but as we progress, we'll go to complicated questions too. Okay. I think something you are seeing here, but this is also very, very simple. Let's use our knowledge which we have just learnt. Okay. If this is 36, consider AB is the arc. AB. AB is creating angle at D and AB is also creating angle at C. See, AB, I will use the marker pen. Yes, sir. Look, AB is creating this angle 36, AB, and AB is also creating C. Are you seeing? It is created. So this angle has to be equal to this. In our example, we learnt on the top, but a arc can be on the top and make an angle at the bottom too. So this is 36, this is also 36 because created by AB. See the lines coming from AB, and AB is also creating one angle here. So 36, and this has to be 36. -36 okay. Now if this is 36, this is 84, how much will be this? So 180 minus 36 minus 84, 60. This I got as 60 degrees. Why? Because the sum of the angles of a triangle is 180. If this is 60, now look, DC is making an angle B and DC is also making angle A. So if this is 60, this also has to be 60. Now what about Y? When two lines intersect, the vertically opposite angles are equal. So if this is 84, this also has to be 84. Y is how much? 84. Okay, I hope you understood. So my request is you open this exercise on our website examprep.world, go to circle theorems, go to this type of questions, type 4 questions, and these are type 4 only, no? Type 3 questions. Go to type 3 questions and draw each diagram. Okay. When you draw diagram, your mind will register which is an arc, which is a chord, how the chords are making angles on the circle. It can be from top to bottom or bottom to top or at the center. So when your hand, the muscle memory is very important. When your hand registers actually a lot of things when you actually draw. So my request is, it will take time, but rather than understanding with just video, also practice while doing your questions. Okay. Go to the website, open the thing, draw with your own hand. Okay. And then mark this, then you will understand. Okay. We have next questions here. Now what is this cyclic quadrilateral? So theorem here is, cyclic quadrilateral means quadrilateral in a circle. So A, B, C, D. Whenever you have a cyclic quadrilateral, which is quadrilateral, which vertices are touching the part of the circle, all the 4 vertices, then opposite angle A and C and B and D. So A plus C, opposite angles, will be supplementary. So this plus this is 180 and D plus B is also 180. The angles are supplementary. So you can say theorem is opposite angles of a cyclic quadrilateral are supplementary. Okay, diagonally opposite angles. So if you have 71 here, this will be 180 minus 71. 180 minus 71. $109. How much it is? 109. And this is 94. How much should be this one? 180 minus 94. 86. Now from here to here is a straight line. So this is 180 minus 86, which is 94. Okay. Easy to solve. So we used the theorem that cyclic quadrilateral diagonally opposite angles are 180 degrees. This was a theorem and we applied it successfully here. Okay. Now let's go for this one. Okay. There are how many chords? 4 chords. AB is also chord, BC is also chord, DC is also chord, AD is also chord. They are asking us A, C, E. Okay. So first we will find this D, because this is a straight line. Let me zoom it for you. Okay. See, this is a straight line, right? It should be 180. 82 is already here. So what should be the D? It should be 98. Right? And if D is 98, mind this is not a center. Huh? This is not center. So don't consider this point as center. This is 98. Okay. Now opposite angle will also be 98. And what is B? Let us find B, because we have 82 and 52. 82 plus 52. 134. 134 subtracted from 180, 46. This angle is how much? 46. Okay. This angle is 46. Now BC, DC, look at DC. DC is creating an angle 46. DC is also creating this angle. So this angle also has to be 46 degrees. Both are created by DC. Look carefully. DC, look at my finger, is creating angle B, and DC is also creating an angle A. Both have to be equal, but it's created by the same chord. Now, if this is, look at AB. AB is creating an angle at C, which is 52. AB is also creating angle D. So this also has to be 52. Correct? Now, only one angle is left, E. This whole angle and this angle together is 180, I told you. They are angular supplementary. So 51 plus 46 and 52. And the balance is how much? If this is 51, it became 52. So 46 will become 45. E has to be 45. So let's check. 51 plus 46 plus 52, 31. What? E is 31. I'm so sorry, E is 31. Because the sum of this angle and this angle has to be 180. So with that, we got that angle is 31. Okay. So all angles done in this diagram. Okay. See, with me also, when I see a big diagram on the board with very short distance, sometimes I also get confused. Okay. Ignore those things. Because when I do it on a notebook, the notebook is quite far off and this diagram is small. My brain is able to accept things. So that's why I always tell you, you also write it on your notebook. Okay. Because you're seeing video, fine, you will understand. But writing on notebook is very, very important. Okay. Here we will use our isosceles triangle story. Okay. If this is 49, this is radius, this is radius. How much should be A? A should also be 49. Why? Because in isosceles triangle, if these two sides are equal, the angles will also be equal. What does the triangle theorem say? If in an isosceles triangle, angle adjacent to equal sides are equal. So see, this is radius, this is also radius, both are equal. So this angle should be equal to A, 49. Now, angle B and angle D are also equal. Now this, what kind of triangle is this? Triangle in a right angle triangle, triangle in a semicircle. This whole thing will be 90. So 90 minus 49, 41. So B is how much? 41. Okay. Now if B is 41, D should also be 41. Why? Because see, this is radius, this is radius. So this is again isosceles triangle. This also has to be 41. 41 degrees. Okay. Now, can you figure out C? 49, 49 is how much? 49 times 2 is 98. 98 minus 180. Subtracted from 180, so this is 82. So this is also 98 because total angle is 180. So figured out all the angles in this particular sheet set. I'll move away, pause the video, do it yourself. Yes. So let's go to the next set of questions we have here. Let me zoom it for you so that you can see. First, let us do this one. AB is creating so many angles, C, D and E. All angles should be equal. So let us go ahead and write that these angles are equal. So B, D and C will be equal. Why? Because AB is creating, look carefully, AB is creating C, AB is also creating D, AB is also creating E. Three angles created by same arc, so they have to be equal. So this is 35 degrees, this is also 35 degrees. Okay. Now look at who is creating 11. ED is creating 11. Look, ED is creating 11. ED is also creating angle, this one. So this has to be 11. Although they are not asking, but still this 11. And who is creating this 26? DC. DC is creating 26. So this part is 26 degrees. So C is also 26. Look at, see, DC is creating 126 here. DC is also creating 126 there. Angles have to be equal. So what is left now? D. Now you have a triangle, this triangle, where you have 11 and 35. Can you find D? Because sum should be 180. So you have 180 minus 134. D is 134. So all angles of this triangle is done. Go slow. Pause the videos at every instant, right? When you are not understanding, look back, go back, move forward, right? That way you will be able to get all the questions. Now let's do this one. This one. How will we do this question? AB is diameter. AC is creating some angle at the center, and AC is also creating some angle at the segment. I told you what is the relation. This should be double of this. So A should be half of 56. What is half of 56? 28. Once again I am telling, an arc, when it creates angle at center, it creates half the angle at the segment. Okay, 56, 28. Easy to understand? It was a very easy question. Let's move on to the next one. We have a cyclic quadrilateral, we have so many things. Look, AC is creating angle 53, AC is also creating angle at the center. So B has to be more than double of 53. Double of 53 is 106, correct? So B is 106. How to find this A? 53 and A should be 180 degrees. So 180 minus 53. 127. A is how much? 127 degrees. Why? Because this B and D are together 180 degrees. Now what is left with us? This angle C. How to find angle C? Join this line. This is 32, so this is also 32. 53 minus 32 is 21. Because the whole thing was 53, 53 minus 32 is 21. So angle C also will be 21. Why? Because this both are radius isosceles triangle. Okay? Easy to understand? Pause, do yourself. Go slow or slow down the speed of the video. Okay? And if you are understanding, increase the speed. Okay? So next. I hope you have understood all these questions. Let's go to the next set of questions. We have some more here, 3 more. Let me zoom once again for you so that you can see. Zoom, 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 zoom in, zoom. Further you want me to zoom? Okay. Zoom away. So, yeah. Let's do this one. Okay. So, what about this triangle? This one and this one congruent. Why? Because 90 degrees you have a 90 degrees here. From here to here it is 90, from here to here 90, right? This side is equal, this side and this side are equal. So these two triangles are congruent. So if this is 24, corresponding angle is A. This also has to be 24. Okay. Now if this is 24, B is 90, we know that B makes 90. So this is 90 minus 24 is 66. Correct. Now if this is 66, this angle also has to be 66. Okay. Now 66, 66, 122. Why? BDC. Look at this. BOC. BOC, and this is BC is creating an angle at the center and BC is also creating angle D on the segment. So this angle has to be double of this. So E also has to be 66 because this is 2 times 66 and this is 66. All done? Anything left? No. So we have solved that one. Okay, understood. So again I am telling again and again, keep writing on your notebooks. Draw it with yourself, then only confidence will come. Otherwise confidence won't come. And circle theorems, criteria A, definitely you will have a 4 marker plus 5 marker questions. Okay. So be very careful. Don't lose single mark to get a perfect 7. Okay. Now here, come back to this question. This is 48. Now look at this one. Is this isosceles triangle? Radius, radius. They already have given 41. So 180 minus 41 divided by 2. 69.5. B is how much? This is 69.5. This is also 69.5. Why? Because all three angles will be equal to 180. These two angles will be equal. Now they are asking you this angle. This is very simple. This whole thing is 90 degrees. 90, 41. So 90 minus 41 is 49. It was simple, right? So what we are using, because right angle triangle, so if this is already 90, 41, then it has to be 49, because these two angles are again complementary. So let's go to the next one. Here. Okay. Now, $127. So how much will be A? Let's start from here. 180 minus 127, isn't it? Minus 127, 53, right? If this is 53, this is 127. Why? Because this cyclic quadrilateral, look carefully, A, B, C, D is a cyclic quadrilateral, opposite angle should be 180. So if this is 53, this is 127. And if this is 127, this will be again 53. Correct? Right? Because this whole thing is a straight line. Now this 53, 36. Now D, angle sum properties, calculate. So it is 180 minus 53 minus 36, 91. D is how much? 91. Then how much will be E? 180 minus 91, 89. If this is 89, F also has to be 91, because opposite angle should be 180. Opposite angle should be 180. So was it easy? So we started from 1. Once you get hold of the tail of the question, the whole question will come into your grip. Okay, so this is how it has to be done. Understood? So with this, we come to an end on this type of questions. I sincerely suggest that you should open the website and practice questions from there. It will definitely help. Thank you.